So there are a couple of TAs in this call. So I'm going to create out the breakout rooms. I'm going to create out the maybe a 10, 15 breakout rooms, and then people can join just on your own. And so if you and a TA can join a room individually, and then the TA can help you in the breakout room individually. And if you are following along, you can stay in the main room and follow my exercise. If you are following along, you don't have to go to the breakout room and with the TA. So you can actually in the chat window, you can the TA. I make the TA all the co-host. So if you see a user who is a co-host, that is the TA, and they oh, it's a good idea. So for the TAs, you can also change your username, say TA, and then it's become quite obvious. Good idea, Chase. So, and then you can send a chat to the TA, say, can you help me in a breakout room? So, what if you can change your file name into your last name and first name, and then with other thing. So, and then you can also see there's a share button. You can also send out a link to the TA. And then the TA can actually see the sorry, the thing of working at home, you have kids running around. And then you can share that link to a TA. Okay, so so there are some images in the file. So this is to show you the manual file, editing, view. In fact, you see a runtime. This runtime actually is very useful. So if I just click some cell, I can just click run things before or run after or run select. I guess the most important thing right now, you want to know what's the difference between the code cell and the text cell. See what I'm highlighting here, there's a code that's at a code cell, and there's a text says text cell. And on the left-hand side, you also see the table of contents. In fact, if you click the table of contents, you can jump into different chapters. So there, now I'm in the chapter 1. I can go to chapter 2 or chapter 3. So my goal is to go over the basic preparation at chapter 1 today. And then tomorrow we go over the actual COVID analysis and the visualization. And Monday we can do some more advanced, like a mobility, maybe temperature, or even some optional one. Especially some of you want to analyze your own hometown or location. So okay, so one thing is in the Google CoLab, you see in most of the sections, there is a triangle next to it. So right now, if I click on that, you see that's the minimize. So if I click the triangle now is horizontal. So that means that section is minimized. So there. So if we click that triangle, so this is chapter 1, chapter 2, chapter 3. So right now I'm minimizing all these chapters. So I actually had a typo there. So there. So that's the first preparation 1, preparation 2, chapter 1, chapter 2, chapter 3. So if I click one of those triangle, right now it's a horizontal. If I click that, it's vertical, then I'm expanding that chapter. So now you see the chapter 1 basic of R is expanded. So if I click back, now it's minimized. You see there are 51 cells hidden inside of that. And if I click that 51 cell, it's going to open. So and those shaded cells, those are the code cell. And the white one, so for example, this is the white background cell. Those are the text cell. So text cell is just a document, it's a comment. It actually doesn't run. But if the code cell, see there's a play button. If I click that play button, well, it says warning. Yes, let's run it anyway. I wrote it. Hopefully, it's okay. It's not going to blow up your computer. It's okay. So there. So I click that play icon. Now it's run the code cell. So this is just a very simple R code. So I think I covered that. So 2 plus 4, the plus sign is the simple algebra. There are other algebra calculation, 2 star 4, that means multiplication. 9, this backslash, that means divide. 9 divided by 3, well, what's that? 3, okay. 9 minus 7, good, that's 2. So you can actually now change this. If I change, say, 9 minus 5, well, that's 4. 9 divided by 2.5, and 2 times what? 3.14. So now, okay, 6.28, correct. 9 divided by 2.5, apparently that's 3.6. 9 minus 5, that's 4. So this is a simple calculation of R. So I'm going to let you do this, a few exercises, and change a few numbers. And then, so let's, oh, there's one user say not following. Chase, can you, can that user send a chat to Chase? Chase Carroll, TA, can you?
Yeah, whoever it was that wasn't following along, in your chat box, you can change everyone to send a message to one specific person.
Mm-hmm.
So send me or one of the other TAs a message and we can help you out.
Yeah. Okay, can we clear out a yes or no? I'll now see whether you, if you, the question is, are you be able to run a simple calculation? If you can, click yes. If you cannot, click no. The person who clicked, oh, I see that the no disappeared. Okay. Well, good. So, okay, so I'm going to, okay, now clear all the yes or no signs. So I'm going to move on to the next section using variables. So, so in most programming language, we have this equal sign. This sign actually is not a mathematical equal. That sign is something called assignment. So for example, I say x equal 2, that means assign to the as a value to x. Now basically say x is what we call a variable, but what's the value of x? That will be 2. So and then the next one will be okay. So assign 3 as value to y, and then guess what will be the x plus y? You can send that into chat window. 5, yay! This is nice. Wow. The Zoom probably need to modify its window, and somehow I can minimize all the answers. Right now I see almost like several dozen lines of 5 here, so I have to scroll up to see it. so someone probably can send a comment to Zoom. They need to improve their user interface. If I can minimize all this 5 into one line, it will be helpful for me. So, okay, it's good. So yeah. So I can run this cell and this, I got 5 too. Good. So CoLab is working. So another thing in CoLab is this, I guess that's called pound sign. So if I type a pound sign, that something means a comment in R. Basically, a comment is not a code. It's not going to be executed. So if I say a comment is that line, you can type anything. Well, we can add some informative comments here. Right. So we can actually add that comment after the code. Actually, I already did in the previous cell. So so the difference between the code. Oh, I need to also print out X and then see a result. So the difference between the comment and code, if I added that pound sign in front of the code, then nothing will happen. That basically means there's no executable lines in this cell. But if I uncomment, and then the execution part will come back. And this is also is a good trick. Generally, good trick in coding to debugging. So sometimes when you want to debug some code and you want to make some change, but you still want to keep the code there, a comment and uncomment is a good trick to learn or to use. We can comment this line and then uncomment and see what happens. This is a very convenient way to figure out the bug. Someone is asking a question about the double slash. That's actually probably in C or C++. It's in R, we do not use the backslash. In fact, double backslash probably has a different meaning in R, but I don't remember right now. So yeah.
So I have a question about the end goal. So I was looking on the website and it said the submission of reports and videos due. And how will they be graded? Like, how will we see that one person's presentation is better than the other?
Presentation, we are not going to grade on presentation, but the video presentation is really just for you, for us to have something to show and for you to have some fun with this. It has to be meaningful, informative about COVID-19, maybe coding on what kind of story you can tell from we can actually talk about later on. It's kind of a bit off the topic right now, but the evaluation actually is not about your performance, because we have a student from middle school to college, so won't be fair to use that way to evaluate people's performance. And we have some students who already know some coding. Apparently, someone know Python and C++ look like. So, and then we have people who never do anything coding. And so it's all about how much participation, how much effort, how enthusiastic you are doing this, yeah, right? So, okay, so let's, so basically this is not a class or competition. It's really just for participation. So, good question. So, let's discuss when we have more leisure time in the back. So at the end. So a good way to a very common way in computer language is something called an array or list or vector, depending on different programming language. Someone is raising a hand. Yes, can you speak up? What's the question you have?
I'm sorry, my mistake.
Oh, a mistake. Okay. So, all right. Okay. Well, your microphone works. So we tested your microphone. In R, it's called a vector. In Python, it's called list. In C++, Java probably called array. So this is, here we are specify a list of numbers or vectors in R. Now we actually have this C in front of parentheses. So that's basically, I still do not remember what C stands for. It's probably for container, something similar to that. That's how I remember this. So we have a C parentheses with some numbers, and then that will be a vector. So if I run that line of code, and then we have a vector which is 1, 3.14, 5, -1, and 10. Okay, so that be a vector of A. And then we can also have once we have a vector, and the advantage is now we can do computation or a modification on the entire list of vector. We don't have to do it individually. So before, you see we have a 2 plus 5. What if I want to add 5 to 100 numbers or 1,000 numbers? Right? So, and then I cannot do this one by one. And the good thing about the coding and programming is we can let the computer do things to many numbers at the same time. Right? So here I have a vector which is 1, 2, 3, 4, 5 numbers, and then I can say A. Oh, actually here I added the 1, 2, 3, 4, another 5 numbers. So a vector add that 5 number, I assign it to B, which is a different vector. So there, is that correct? It seems so, because -10 plus positive 10 is 0. -1 plus 1 is also 0. -5 plus 5 is 0. And the previous two probably also correct. Yeah. So, and I'm going to pause a second, let you do some exercise here. So you can actually add, if you click that add code, and let's do something else. How about we have a C vector, and the C vector is A vector add a 10 to A vector. Let's do that. And you can type your answer to the chat window. So. Okay, I see a correct answer from from Emily McDonald. So very good. So so we can put a vector plus 10. Oh, I missed I missed that sign, equal sign. See, and then we can print out the okay, so that will be addition to a vector. Okay. Okay, so also you do not need a C here because C is actually, you only need a C when you assign specific value to it. Okay. Mine says cannot find a vector. Okay, Lucas, can you share your screen? So I'm going to stop my screen. I want to see what's the error information you have. Lucas Batista, can you share your screen?
Yes, sir. Can you see it?
Oh, you have not run the previous A vector yet.
Oh, okay.
You need to, yeah, the code is actually,
oh, yeah, I see it now.
yeah, the computer has a memory too. If you run the number 5 section, then the computer will remember the A vector. If you have not run it in the memory of the computer, it actually doesn't know what A vector is. So then when you execute A vector plus 10, it's going to say, I don't know what A vector is. So it's good. Thank you for sharing your screen. So,
thank you.
Yeah. Okay, good. So let me go back to my own screen. So. Okay. Anyone else had trouble here? If you have trouble, you can click no or raise your hand. Okay. Seeing none, I'm moving forward to the next section. So, so imagine we have a list of 1,000 or even 1,000,000 numbers. It will be really perplexing to find out what number is, say, in the 100th position, right? If you right now we have just 5 numbers, we can tell the first, second, third, fourth, and fifth. But imagine we have 1,000,000, like a telephone number. There are actually 300 million Americans. Probably at least 80% of them have a cell phone number. So if you want to put all that in a list, how do we find out the particular person, right? So I'm sure that a telephone company has something like that. So this is in computer language called indexing. So in this case, in this cell, I'm going to, how do I do that? I'm going to have assign the number from 4 to 20. That column sign means from 4 to 20 by default is go by 1. So now I have a vector which is 4 to 20. And the way to indexing in R is using this square bracket. So a vector square bracket of 1 means out the first element of the vector. So number 4. So and a vector square bracket number 5 will be, is that 8? 1, 2, 3, 4, 5. Is that 1, 2, 3, 4, 5? Yes, number 5 is 8. Okay. So, and then the question is, how do you find out the 9th element? You can type your answer in the chat window. So. Very good. Yeah, I see someone put it there. So, a vector 0. That will, what happens if we type a vector 0 there? It's probably an error.
I think that was just a typo because 0 is next to 9.
Oh, I see. Okay, good. There's nothing there. I'm actually surprised there's no warning. What if I type 10? Oh, 10 is actually, what if I type 99? It should give me hopefully give me an error. It actually gave me not available. It means there's nothing there. So why is the 0 even indexed? Yeah, that's a good question. What if I say -1? Oh, I know. So the R actually have an interesting way of indexing. It also can go backwards, apparently. So let's just skip that for now. So let's just stay with the simple syntax. So 1 is there. So yeah. Yeah. So the 9th element 9 will be 12. Is that 12? That's correct because it's just in fact we can actually say not -3. Yeah. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 9th element. Wait a minute. Oh, because they are not the same letter, so it doesn't align very well. Well, okay. But I guess you can count it. 9 is probably 12. So 9 plus 3 is 12. So yeah. So. Okay. And oh, someone actually used a Lua. That's actually a very. I'm actually quite surprised someone used a Lua. That's a not very popular language. So impressive. Okay. Okay. So the next thing, well, if you have used a calculator, you know on the calculator there are many buttons. Those are predefined.
Where did he go? He ran away.
Probably had something important to tend to.
My apologies. I have to close the door to keep the kids out. So,
Roberto,
okay.
I noticed that you have your hand up. Do you have a question that do you want to ask the whole group or do you want to ask one of the TAs?
Yeah, sorry, it's my mistake. Let me I'm very new to Zoom, so a little bit of a problem. So okay.
Oh,
now it's
okay.
fine. Sorry.
Well, it looks like everyone is new to Zoom every day because there are new features. I don't know how to use myself. Okay, so the function in R or in many languages is just something called predefined procedure. Right? So if you have a calculator, you probably have something called there's some button called square root, something to calculate sine, cosine, log. In fact, I don't even know how to calculate a log by hand for many numbers, right? So, but someone has built a procedure to do, say, the log, and put a button on your calculator. So you can put a number there and push that button, it works. So in most of our computer languages, we can also define a procedure ourselves. We can, very often we call that a function. In some language, we call that a method. Probably in Java, it's called method. In R, Python, C, many languages, we also call it a function. So there are many predefined functions. And in R, this example is seek. It basically generate a sequence of number. So what this number is actually generate from 4 to 100 with a step of 2. So 4, 6, 8, 10. Those are just well. If I change this to 10 or 1, that basically is just what? That basically is 4 to 10. So, but if I generate that means goes 4 to 100 with a step of 2. And so the function also uses smooth parentheses. I'm going to delete this so it won't be confusing. So there's a delete button next to the cell. I can just delete that. That way it won't be confused with the X. So I have the text, I have a code. If I change the code without changing the text, then the next time if you look at it, it will be kind of confusing. So and so the next cell, I have the R null. What is that function? Actually, R means a random. Norm, N-O-R-M, normal. That actually means normally distributed random variable. Very often we just call that random variable. And when we say random variable, usually that's what it means. It's also called Gaussian random variable because it's the bell shape. Probably first described by Gauss. And now, did I say Gaussian? Gaussian, sorry. Yeah. So now what this does is now I generate a 100 random variable for X. And then I also let Y become a random variable of X plus some random noises. So Gaussian noise is very common. It's also called white noise. And what this is just do a linear regression. So basically, I'm going to plot a straight line from a straight line between Y and X. So, and then I'm going to plot, and this is something called scatter plot. So Y will be the vertical axis, X will be the horizontal one. And then we actually add a line. It's called AB line because A is the slope, B is the intercept, so AB line. And this is actually a report. I just reporting. So if I run this play button, this is actually now doing a scatter plot of Y over X, and also have a linear regression between Y over X. Well, it's basically, this is clearly is a line because that's how I specified it. So we have a Y over X with not surprisingly a small p-value. Yeah. So we're going to go over that later on. But right now, this is just to show example, we can use a plotting function and LM for plotting a straight line. And if some of you have used Excel, you know in Excel there's something called a trend plot. This is this is very similar to the trend plot. Well, in fact, mathematically exactly the same. But this is how we do that in R. And for now, let's you can just learn to run the code. And the point is, those are the functions we are using: rnorm, ln, plot, upline, summary. Summary is that this is what the summary reported. So for now, we can just ignore it. But for some of the college students, you probably already you can read into it. So okay, but this kind of what if you many of you are new to R? In fact, I still have many things I don't remember in R. But how do we find out? Let's say if I don't know how to use R now, if I don't know how to use a plot, outline, summary, how do we find out? We can just type the question mark. That's the way in R to find out the help information. So once I run this section or a question mark R now, you see here, on the right-hand side, we have the help menu popped up. So norm is actually say the normal distribution. That's is actually this function actually has several forms. For now, you can ignore. That's actually for density, probability, or Q value, which is the other way around. And then the R norm, which is actually a random number. You can actually scroll down to actually read this. Those are basically it's probably like when you if you buy, some of you probably buy a toy. There's a menu. This is basically a menu for this toy, R norm. You can actually read. For now, we can just ignore it. And we can also look for the LM help menu. The LM fitting linear model. That's basically is a straight line. A linear model is a straight line. So that's what the LM is. So, and then we have the upline. The upline function add straight lines to a plot. So, sorry, A is the intercept, but B is slope. I think I say the other way around. Yeah, so A is the intercept, B is the slope. So it's a good thing we have this help menu because it's just too many technical details for us to remember. And in many cases, it's actually not that important. You remember all the technical detail. The good thing is you know where to find it, right? So we have all those menus. When you need to use it, you look at the menu and then know what to do. So, in addition to that, the question mark, we can also use the help command. Right? So help seek will give us the same thing. That question mark is, I guess, is you only type one question mark. Help. You need to type help for plus 2 parentheses. You need to type 6 times more, right? So, so we can actually see that the triangle sign. You can actually close it, and then you have more room to do the editing. So, are people still following? If you need help, click no or raise your hand, and then the TA will try to help you. So. Okay, so now we are going to also use something called the library. So the library is more like a larger collection of functions we can use, and those are written by many software developers have been tested. So it's almost like when you have a phone, you add an app. So those are a library is just like the app on your phone. You can load it on your phone. If you don't like it, you can remove it. Okay. So in this case, we are going to use two libraries, Tidyverse and DPLYR. I still do not know how to pronounce that. They are probably a conventional way to pronounce it, but I don't know. Yeah. So that's actually two popular libraries. Yeah. You can also see inside of those it actually show that Tidyverse actually have the ggplot, typical, tidy, readr, pure, DP. Oh, it already have a DPI already inside, string R and forecast inside. So technically, I don't have to load that library again, I guess. Yeah. So, yeah. And once we load those libraries, we actually can use those libraries to do some exercises. Yeah. So, and the next section will be about data frame, and it's probably one of the most important concept of skill in R. So data frame is almost like a spreadsheet. Most of you probably use Excel. In Excel, there are a large a table called spreadsheet. The data frame is the term we use for the R language. So it's actually, once you know how to use the data frame, it's actually, in some way, it's offer you many advantage the Excel spreadsheet does not. So in this case, we are going to load kind of a toy spreadsheet from a website. Actually, I wrote that one myself too. So if I run that line, it's going to load a spreadsheet with student name. There. So I load that spreadsheet. I assign you a variable called TB, short for table. So the TB is basically a spreadsheet with 4 columns. The first column is the name. It actually has something called character. And second column is GPA. That's actually is the number, probably double precision floating point. Major, which is again character means word, and then college. Assuming all those people are in a university, they go to different colleges. So George Washington is a very good student with 4.0 GPA, had a biology major in the College of Art and Science. That must be the University of the United States. Okay, so and then we have other student name there, and with the GPA major and the college there. So and if you have trouble to load this, click no or raise your hand. Otherwise, I guess do nothing. Okay, so. Okay, I don't see any hand raised or no red sign. Very good. So well, right now, if I click TB, I see the entire table. But usually this is not something you really want to do for a large data set. So there's one command called head. Just look at a few rows of the table. So if I, in fact, it's probably 6 rows. 1, 2, 3, 4, 5, 6. Yeah. So that's head TB will just look at the first 6 rows of the table. So, and we can also use indexing to pick rows and columns of a data frame. And remember, on Excel spreadsheet, you have a row number, you have a column name, and if you want to look for a value in a specific row and column, you just use a mouse, scroll down to find it. Right. So in a data frame, remember this is a programming language, and in fact there is no mouse for you to scroll. So we actually, but the good thing is we actually can tell exactly the location to pick those numbers, right? So in this case, we use the square bracket again. Remember, in the vector, we use square bracket to pick the positions, like the first, second, we use square bracket. But now we have the data frame, we again use a square bracket. But now we have the rows and the columns. So we need 2 different information. And this actually can be separated by a comma. So it's a value before a comma. So, so that means the first row. And the value after that comma means column. So if I pick 2, that actually is the value of the second column. But what if I, what I'm doing here, this is actually picking 2 to the third rows, and the second and third columns. So yeah, so that means we can go back and double check second 3.5, 3.9 computer science. If we go back to that table, second, oh yes, that's correct there. So second row, third row, second column, third column, that's exactly is there. So, okay, so we can also do a bit more customized. So I can remember that the C, we can specify the rows more specifically. So this will be the first, fifth, and the 9th rows, and the first column, second column. So, well, yeah, I remember the first one is George Washington. The 5th probably is James Monroe. Is that 5th? Okay, 1, 2, 3, 4, 5. Yes, James Monroe. 6, 7, 8, and 9. The 9th is Millard Fillmore. Is that? Yes, that's correct. So, so those will be using indexing to pick rows and columns. So we can also use another symbol to pick columns. We can use something called the $sign. That actually is also convenient in many ways. So in this case, I'm picking what? TB $sign GPA. So I'm only picking that column of GPA. This is basically the same thing as the comma 2 with a bracket. They are the same thing actually, but it's just different way to do it. But picking the rows, and right now, as far as I know, you have to use a bracket. It's yeah. So maybe in future version, there's some other things to do. Actually, using a different package, maybe you can do that. Okay. Anyone have trouble? Need to raise your hand or click the red button. No. Okay. It looks like people are following. So, okay. So, in addition to those basic indexing, there are also a popular way called tidyverse. And for now, you can, and since this is really a beginner R coding, you can just know this runs, and because the tidyverse is an entirely different flavor. This is almost like I don't know many new things. Like there are many new words or apps or social media I don't use, and many things I don't know. But so those are the old ways. But the R language is also evolving. There are new ways to do things. So the tidyverse is almost like the newer thing to do some can do things in more I don't know, fancy ways. Let's just put it that way. Yeah. So this will be instead of using a $ square bracket. So we can use the percentage arrow sign redirecting the table. So this here, this is almost like a direction. So I'm going to say put the table into what? Into the select function from that package. That double column sign means there's a function from that package. Select. What I'm selecting here, we are selecting two columns, name and GPA. So that's select. And then we are going to follow up with another function called filter. In this case, filter is actually by rows. We are going to filter all the rows with GPA greater or equal than 3.0. So there. So, and the question is, what if I want to pick the GPA greater or equal than 3.5? And you can type your answer into the chat window. So. Very good. Yeah, I see Mariani Alvarado. Good answer. Oh, there's also another one. Nicholas sorry, I don't know how to pronounce your name. Sorry.
It's Jejos, Professor.
It's what? JJ?
Jejos.
Jejos. Oh, thank you.
Yes.
Okay, so if I change that to 3.5. Yeah, very good. So in fact, we can actually pick 3.9, pick even higher one. Oh, wow. So this the Franklin Roosevelt. Oh, we have two Roosevelt are all very good students. Yeah, James Madison, George Washington also have 4.0. So very good. So it's actually safe to play the name with the president. It's a bit tricky to play with other people's names. So, okay, so we actually can also do some other exercise. So, so here we are now picking, trying to, this is how many colleges are there? Basically, if you look at this data, art and science, engineering, business, but how many colleges? You can count it by eye, but we can also do it more. Since we are writing a code, we can also write a code to find this one out. So, so what this is trying to do is we have the table. We can just select all the college. We then find out the unique one, the distinct ones. So, art and science, engineering and business. So there are 3 colleges in this data set. Okay. So the next exercise, so now we're actually trying to going a little bit of a basic statistic. So I'm going to pick the GPAs from the College of Art and Science, and then from the College of Engineering, and then I'm going to. The question is, the student in the engineering have the better GPA, or the student in art and science have better GPA? We're going to compare the 2 GPA of these 2 student populations. Now, how do we compare? We are going to compare the average GPA. So basically, we are going to compare whether the student in art and science and the engineering, whether the average GPA is so-called statistically significant or not, statistically different or not. So, and basically, if there are probably a little difference there, but are they statistically significant or not? Basically, those differences due to chance. So, so I'm going to first. So this is how we found out the using filter to find out the college student from the college with only art and science. So we can actually see here. That's the student from the College of Art and Science, and then the bottom one. Now those are the student from the engineering. Sorry, let me close the door again. So once we pick those, I'm going to assign them into a separate table. So the engineering, I'm going to call that TBENG for table for engineering. And then the other one I'm going to call the table for AS, table for art and science. And then I'm going to compare the GPA of these 2 groups of students using something called the t-test. And that's actually quite appropriate here. T-test is the student test. So, so this is the 2-sample t-test, and it actually compare the mean and the average value or the mean value of these 2 groups of students, whether they are whether the difference there are due to chance or not. So here we actually have a p-value is 0.55. So generally speaking, if a p-value is greater than 0.05, means there's no statistical significance of the difference between these 2 data sets. So in fact, you can actually read the Wikipedia page on the p-value. There's a very good plot here, very good figure here to explain what that p-value is. So the p-value, assuming that's actually is like a Gaussian distribution, like the random number generator we use, is a bell shape. So the p-value basically is for the one side. This is actually the one-side test. The test we did is actually 2 sides, but for one-side test, this is basically this part. And if this part is very big, the one we got is like 0.5. That means almost half of this. So means this is not a small, it's not a significant event. if this area is very small, like usually say less than 0.05, and then the chance will be very small, then we call it statistically significant. That's what they colloquially means by this. Okay. So let me. Yeah, so it looked like, amazingly, I finished this chapter 1, basic R of coding, basic R coding. So I'm going to let you play with it and then answer some questions. So I can also let someone can someone volunteer to share their screen? Who is this? I'm going to Cindy Andrew.
Andujar.
Andrew, could you share your screen?
Let me.
Oh, let me stop my sharing. So.
Okay. It's telling me that I have to open system preferences.
Oh, yes, you need to allow Zoom to. Okay.
Yeah.
Okay.
Let's see. Okay.
I thought you already did that.
It's saying.
Yeah. Can you probably can just move that window.
Yeah.
So
There we go.
Excellent. Yeah.
So you want to see it from the beginning, or?
That's fine. I'm just obviously you already know how to use some basic CoLab, so we don't have to. Very good. So everything runs. Nice. Yeah. So thank you. Okay. Who else want to share their window? I'm going to pick someone from the second page on my window. So I'm going to pick Trinity Young. Are you there? Hey, Trinity.
Yeah, I'm here.
Oh, can you share your window? Oh, you have a very colorful background. Nice. Yeah. So, you look like you also minimize the table of content. This is a good trick. So if you want to see a wider range, you can just minimize the table of content. Very nice. Yeah. Okay. Good. Thank you. Can you stop sharing? Okay, let me pick someone from my third window. I'm going to pick those with the pictures. So, Georgiana, right? Are you there? Hello. Okay, so let me pick a different one. Anna Guo, can you share your window?
Yeah, I can do that.
Thank you.
Do you see my screen?
Yes. Okay. Very good. Yeah, it looked like yeah. It obviously things wrong in here. Yeah. Okay. Can you run the t-test part?
Oh yeah.
You can just click oh, it is still running. Oh, you run everything before. Okay.
Oh yeah, I was just trying to run everything before because I didn't get to run everything yet.
Okay.
And then...
Okay, very good. 0.055, I see. Okay, very good. Thank you. Can you stop sharing?
Yeah. And you said it's not significant, right? Because the p-value is too big?
That's correct. Yeah, there is no significant difference between the GPAs in art and science and engineering. That's correct.
Okay. Thank you.
So, okay. All right. So I guess we can move on to the next part. Actually, let me also go over the other preparation. So let me share my screen. Okay, so before we move on to analyze the COVID-19 data set, first we actually need to know what data set we are working on. This is actually the, so the Wikipedia page actually has a very good summary of these COVID-19 data sets. Because the range, how probably every society, every country, many countries has been impacted. There's a lot of effort people to do the so-called open science or open data set. Many people put their data set for public use. One of this is from the Johns Hopkins University. And that data set is actually put on the GitHub. In fact, no, that's actually didn't link it there. So maybe here. Johns Hopkins COVID-19 data resource. Okay. So this is where the Johns Hopkins COVID-19 dashboard. And this has been really evolved quite a lot. It used to be a much simpler. The interface actually changed very rapidly. So right now you actually see even the state tracking. So well, Tennessee is red. Yeah, no, that's California. Oh, actually, this is arranged in the U.S. map shape. Yeah, so Tennessee is in the middle. California is the west coast. That must be Maine, Rhode Island, PR. Is that Puerto Rico? Is it Puerto Rico probably there in the Caribbean area?
Yep,
Florida.
it is.
So, AK. Oh, Alaska. Okay. Alaska is way out there, up in the north, I see. Northwest, so AK Alaska. So, and this is where we get the data set. The data set actually is JHU COVID. It's actually on the site of the GitHub. It's this one. This is where we are going to use this data set. So that's the CSSE. I think that's college. What is this? Sorry, Center for System Science and Engineering, CSSE, at the Johns Hopkins University. So COVID-19 data, CSSE COVID-19 data, and that's the daily report, the US CSSE time series. Okay. We are going to just use the time series. So here they are confirmed US, confirmed global. They are also death US and death global recovered. So, so if I click that, Oh, I see. It's because the now it is so big it doesn't even show it. Let me see. Can I still? Oh yeah, actually. So those are the obviously. I mean, because there are so many number dates now, it's hard to see visually. So
Question about the Google thing where you run the code. So is this running at like UTC or is it running in like Google Cloud or something?
oh, that's in Google. Google CoLab. That's it's from Google.
Yeah, I
That
was
is
curious
Goo-
because
yeah.
when I was using it, it seemed to like keep freezing up. So
Oh,
curious about that.
where are you located?
Dayton, Tennessee. It's by I think where is it?
Huh.
We're in between three big cities.
I see. That's okay. So Tennessee, you shouldn't have trouble with CoLab. So I don't know. But the CoLab is offered by Google. That said, it's a free service, so obviously we don't expect the most the fastest the CPU GPU there. So it's free, but the good thing is it is free. So in fact, because it's free, we can run Python and R code there, and many of the data set is also free. We can load it directly into CoLab. That means a student, even when they have a limited computing power, they can still run it on the Google CoLab. But it is slow sometimes. But given, I guess given it is free, I guess it's not perfect. Yeah, but still, what it means is it could be from running. No, not really, because Zoom and the CoLab, they don't really compete. It's not really competing your own computer resources. Yeah, so the Zoom, of course, is using your own computer CPU and power, memory too. But the CoLab, besides the web browser and the streaming, the speed of the CoLab running shouldn't be affected by Zoom. So, yeah. But that said, if you have a slow internet, it may take some time for it to refresh and coming back to you. So if you disable your video, maybe it run a bit faster. So also means if you are not in a Zoom, right? Obviously, you are not looking at my screen, so that takes some bandwidth. So if you are running the CoLab, when the Zoom stop, hopefully at least your network speed will improve a bit. So, yeah.
Well, I was wondering why it was lagging because I'm running it on the latest MacBook Pro and my internet's a-okay at like 10 megabits a second.
Then I don't know. So
that's why I was curious. I was like,
yeah,
should be running like
that. Yeah, and then then unfortunately there are many things, but yeah. Okay, so actually now we actually can. We still have a few minutes. We're supposed to 1:30 to 3:30. Let's just go over that part so quickly. So we have so we may even move this a bit more. So anyone need help right now? Raise your hand or put a question into chat. Yeah. Yes, we could until 3:30. So let's. Okay, so We are now going to retrieve the Johns Hopkins COVID-19 data set and also learn some R along the way. So we are going to use Google CoLab, and we are going to retrieve those data set directly into CoLab. So this is, the data is not going to stay on your own computer. Let's say that you actually can do this on your own computer if you really want, but then of course, depending on people's computer system configuration, it will be a bit more troublesome for us to help every student work in different ways. But the Google CoLab, the good thing is everybody using the same platform. It's easier for me as an instructor to deliver the content. So because everybody is running in exactly the same environment. So so we're going to install some necessary packages. CoLab, because it's actually officially still not a fully developed, it's still a beta version. It's called Google Research something. Yes, actually you can see CoLab research.google. So it's not officially it's not a business product. It's for research only. So some of the packages doesn't even have. So we have to, in this case, we install that package and then load it. So it's probably take a few, half a minute something. Okay. So in this case, we have the tidyverse reshape to lubricate. That's actually for time to convert the year and the date. And then we also have the library something called ggplot to have some very nice plot. Okay, so once that is done, that's the magic command to load the COVID-19 data set into the CoLab and also into a data frame in R. And all this is done by this, read CSV, URL, HTTP, that's the address. In fact, where is that address? There. That's the address I copy paste into there. That's the address for the data set. So that's the address I just copy paste into that line. So if we run, if you click the play button, wow, it's amazingly fast. It takes less than a second something. Yeah. So it loaded. Now we have the TB there. That's the Johns Hopkins COVID-19 time series data. So this is quite important. So if you have trouble, raise your hand or put a no sign. Or we need to make sure everybody can do this. So if you are okay, so oh, I see. There's a question about what those things means. So, so if you, is it downloading?
It's a big file maybe.
Okay, this is actually numbers, but it's okay. So, so once I download that file, I'll bring it up in a spreadsheet. So you see, those are the columns, those are the values, those are the rows. So column UID, so those are basically some administrative numbers the U.S. Census Bureau use. Admin 2, that look like just county names. Province and state, that seem to be the state name, like Alabama, Butler, Bulla, that probably the county's name. But country is the U.S. And there's also latitude, longitude, and then there's a combined key. And then you have the column, say January 22nd, 2020. That's where the first case of the U.S. is. somewhere there. But you can see when you use a spreadsheet, try to find that value is not that easy. So, yeah. Especially for a large data set. And then January 23rd, well, all the way to hopefully yesterday. So December 18, today is 19, right? So that is December 18 yesterday. Wow, which county had that's cumulative, by the way. But some county has still in the hundreds. There must be a very low population there. Those are the time series data set. It's something called the cumulative. Basically, everything add up. So the total case number is there right now as of yesterday, December 18. And what are those row numbers? Each row is a county. So that's the county of each state. Alabama, and then Alaska, and then Arkansas. Well, Tennessee will be somewhere down below because it's alphabetic. Like Georgia, Mississippi. Well, Tennessee is really, because the T is O, P. There's no state start with a P, isn't it? Sorry, Pennsylvania, that's P. Pennsylvania, Puerto Rico, yes. PSQ, is there a state start with a Q? No, okay, ST, okay. Tennessee, yeah, that's Tennessee. Texas, there's a lot of the T there. Utah, there's no state with X probably. W is the last one. Now Wyoming is the last one. So, well, you see how many counties are there? 3,341 rows. The first one is the column. So there's really a lot of counties there. Actually, some of them are not, but later on we will figure out it's actually quite interesting. They are entered as a county, but not necessarily is actually a county in reality. So, so this is basically the data set. We got it from the website. And so what this means, there are many so-called meta information. Those are the administrative information, right? So location, state, and then there are also the actual cases on different days, right? January all the way to December. So, and those are the data set we are going to work with. So. Okay, so I just showed you how to read that data using Excel. It's kind of informative because that's many of you are familiar with. So when you look at it, you kind of, based on your experience, you can understand what the data look like. But now we come back to R. And if you look at the R and using a table, look at the first few lines, right? So we see the rows again. That's Alabama there, and then columns. Now, now the interesting part, even though those look like administrative numbers, they are also treated the floating number, and those names US are treated the characters. So CHR means character, basically means a word. The DBL means it is a number. Well, latitude and longitude, of course, those are numbers. This is basically the so-called the geospatial information system. It specifies every location on the planet Earth. So latitude will be the horizontal lines on the globe, and longitude will be the vertical one. The longitude, you see the US also is a negative longitude, because there's a U.S. in the western, so-called western hemisphere, western part of the globe. Yeah. So, and then every date there. So, so that's December 18. That is yesterday, and then we have the cases there. So those are the cumulative cases. Okay, so so now using Excel, we can using mouse scroll left and right, up and down to look at the data. By using R, we can look at this just picking at the rows and columns specifically. So, here I'm picking what? The first row, second column, and fourth row, fifth column. Right? So the first row, second column is the US. That's probably correct. First row, second column is the US. Fourth row, fifth column, that's what, the 1007. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yes, it is 1007. And that's for Beaver County, Alabama. Okay, the question is, if I want to see this value, how do I pick it? How do we verify it? If I want to pick this Bullock County from Alabama, how do we do that? You can type your answer into chat window. Okay, someone say TB66. Okay, let's try that. So I can add a new cell and then TB. Very good. Yes. So and remember, we don't have to pick individual. We can also use the vector, a list of number, to pick a more value. So I can pick, say, 1 to 10 row from the first column. So yeah, you can go back and verify whether this is correct or not. We can also pick, say, the 6th row, 7th row, and from the 4th and 8th columns. So, well, we know 6 and 6 is a Bullock, so that's actually quite good to verify this. Yeah. But by doing this, we kind of figure out the daily cases is actually started on the 12th column. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the first day started at the 12th column. So in fact, we can use our function called length to find out how many columns are there, and then we can use that to specify how to pick out the data. So length is the function to basically to find out how long that the R object is. So if I say length, the length of the first row basically is how many columns. So there, wow, there are 343 columns. Well, we are almost 1 year has 365 days, and it started in January 20 something. So yeah, until we reach the end of this year, it's probably going to have more columns there. So, and if this table keep growing, it's going to have probably by the end of next year going to have what, almost like 600, almost 700 columns. Then so so right now from January 22nd to December 18, there are probably 331 columns and plus 12 columns of meta information. So we have 343 columns there. So, in fact, we can pick all the data are there, all the case number there by just specifying the column names. So we know the first one starts at the 12, and the last one is what? The length of the entire first row. And so from the first one to the last one, that will be all the case number of cases. And we're only looking at the first 5 rows. Right? So we can actually pick 3,000. I don't even know what that is. So 306. See how it looks like. Right. So some of them are 0. That's interesting. But actually, once you look at it, it's actually not surprising why there are some places are 0. Okay. And we can select all those. We analyze. We don't want to analyze the meta information. We only want to analyze the actual cases. Right? So so now we can actually pick up. Remember the from tidyverse select pick columns. So we can select all those columns with the actual cases. Right? So if we do that, well, obviously this is a very large table. So, but that's how we can select all this value. Remember, if this is actually the Excel, how do you select this? You basically using the mouse, click the upper the upper left point, and then you drag everything all the way down up to 300 columns and several more than 3,000 rows, all the way to the bottom of your left bottom corner. There, you select all those. But in R, we can just write this line of code and do that. So there, we select all those values, the cases. So, but we haven't assigned that. We haven't assigned. It's not convenient just to look at the entire table without assigning it. So what we are doing here is there's another thing. R actually looking at every state is actually more convenient to look at every county of the column, because that's how R specifies the data, right? Each column we can pick it out directly, but not by rows. So so what we are going to do is we select all those data and we put that into a matrix, and then we do something called transpose. So now, excuse me. By the way, I just did the COVID-19 test on Thursday. It's negative. So if I cough, probably because I talk too much. So okay. So T is for it's something in linear algebra we call the transpose. Basically, in the spreadsheet, what we are going to do, we change all the rows into columns, change all the columns into rows. That's something called transpose. It is something, if you take the linear algebra in college, this is something you will learn in the math as part of the math courses in linear algebra. So in R, we can also do that. We just pick out the value, put that into the matrix, and then do a transpose. T, do a transpose. And then we put it back into what? Data frame. So, and then we actually have a new table just for the COVID-19 cases in the United States. So if we run that, there. So instead of using head, I'm now using, it's the sister command using tail. So I'm now looking at the last 6 rows of this table. So there. So the last row is from yesterday. There are still some counties has 0 cases, which is looks quite surprising, isn't it? But that actually is not coincident because those are very special places. But then many of the counties, well, you can see this county, I don't remember, it must be some county in Alabama. Total number is 11,556. So questions? There's a question, see whether there's the special command for head or tail just for the columns. No, but you can combine the two. You can do a transpose of the column and then use head and tail, right? So you don't need a special command just for column, but you can combine various commands to do the things you want. That's what the programming is, right? So if in this case, if I want to look at the columns without the still using head and tail, and what I can do is I do a TB, TB1, T that, and then look at the head. There, I'm going to look at the first few columns of that. There, so so this, I don't need a special command just for columns, even though the head and tail only work for rows, right? So I can also look at the last few columns using tail, right? There. So there's no special command for looking at the first and the last few columns, but we can combine different functions to do the task you want to do, right? So this is what the programming is about. With all those basic functions, we write our own code to do the task we want to do. So, good question. Yeah. I'm going to pause a minute, so let you try to work on that. More questions? Oh, there's another question. Let me see. What are the advantages of having the matrix? The advantage of the matrix is to use that T command, because transpose only work on a matrix. But data frame is more convenient for data manipulation. But I want to use that T transpose function, so I need to convert the data frame into matrix. Good question again. Yeah. If I do not convert that data frame into a matrix, I cannot use the transpose function. The transpose function only works for matrix. The matrix also has a limitation compared to data frame. The data frame can have different kind of columns, right? So the column can be character, United States dates, but a matrix, it had to be uniform. Everything in the matrix need to be a number, need to be a value there. So this is why we convert everything into a matrix to a transpose. Yeah, very good. So good question. Other
I have a question. So we selected just the columns that had numbers in it so that it could be a matrix, right? So we've essentially gotten rid of our county information.
Uh-huh.
So how would you then, we've transposed it now, how would I then, if I wanted to connect it to which county it is, do that easily?
Perfect question. So there, the next section. So we are going to, it's nice, but this is really confusing. 1, 2, 3, 4, right? We want to add some meaningful name there. So instead of using just 1, 2, 3, 4, the value column V1, V2, we need to, let's add some meaningful names into the data. So it turns out, what's the meaningful name? It turns out the combined key is a uniform name. So when the Johns Hopkins people trying to generate data, they realize they give this information there, combined key. They basically have a county, state, and a country there. So you look at this combined key will be a very informative name for the data. So and then the table counter is convenient because we can like jump back and forth directly into a position we want. So we are going to use the combined key as a new column name. So, and this actually can be done by the command called names. So this is TB1. That's right now is just those really weird column names. But we are going to replace this column name with what? The combined keys. And using the assignment. So there. So and here we're actually looking at the after we assign it, now it's here. The first column is what? Altaca, Alabama, US. Now we don't have to count which column it is. We just look at the name. And now the Bullock, Alabama is here. That's probably number 6. 1, 2, 3, 4, 5, 6. Yeah, so there. Now we have some meaningful name. And this is actually for human to make some intuitive understanding. We often need to look at the word. If you just have a 1, 2, 3, 4, 5, 2 all the way up to 3,000 something, it's hard for a human brain to comprehend what that really means. Yeah. But if we look at, say, Calhoun, Alabama, US, all of a sudden it is more meaningful. So yeah. So we also need to convert the actual dates into the special data type in R. So right now those dates are there, but they actually considered as a word. But the data actually is a very special data type because you think about other numbers, right? So 1, 2, 3, 4, 5, 6, you count the one, it goes continuous. But the date, you have a February, you have January, go to 31st. Well, the next one is actually February 1st. It's not January 32nd, right? So the data has some special range and jump on the back. So you have a January 31st and then next February 1st. And February based on the year, sometimes you have a February 28 or sometimes you have February 29, is that really? And then the next one will be a March 1st and then March 31st. After the March 1st, all of a sudden you go to April 1st, right? So the date has some special range. And if we just use the text, it's actually not easy to do that kind of a calculation. So, but R has a package called the Luber date. That's a special R package to deal with this dates in R. So, we are going to use that Luber date package to handle all the dates. So. And in fact, if we do that, you say date, that's actually a function in the Luber date. And notice I use the quote. That means it's a word. It's not the actual date type in R. So if I say date quote of that, it actually return a data type. That will be October 1st, 2020. Apparently, that's by convention is still the American way of specify it. And because the American way is a month, date, and a year. So it looked like the person who designed the package is also from the USA. And so now if we can actually look current date, remember in the John Hopkins data, all the columns has a special date. It's like the, say, a January 1/22/20. So those are the American convention of dates. So that's there. First /22nd/20, all the way to 12/18/20. So that's the American convention of dates, and that basically is a month and oops, sorry, I typed something. Okay, good, I didn't change. So MDY, so it's the month, date, and the year convention, and we can use that to just convert it directly into the dates. That's the international systematic standard, which is a year, month, and the dates. So if we do that, MDY, that will convert it into the 2020, 01, and followed by 22nd. So that's actually the, in the system, that's the, I guess, more systematic way. So, okay, so the next command will basically, we put all the dates also as the value of the dates as the column here. Actually, it's already 3:30. Maybe I'm going to quickly go it, and next time, tomorrow we're going to review it. So, there. So now if you look at the very last column, the dates, now you see here, this is a special data type called date. And that's actually last day is 2020, December 18. So, we can also, now we actually can filter the dates. Now we can actually filter the dates from what? April 30 to May 31st. So that will be basically the data from May. So yeah, May 1st to the May 31st. We can also specify the start and the end of a date. So at the following, we actually specify. We're looking at the September 14 and plus 13 days. That's just 2 weeks of a window. So with this Liberty package, we can now treat the date as if it's just the decimal number, right? So we can now do addition, subtraction, filtering, greater than, less than. So it's much more convenient. Right? So this Liberty package is very useful to handling the date state. This is also why programming language can be much better than the Excel spreadsheet, right? So you remember, if you put this in an Excel spreadsheet, you want to pick just May. It's not that easy. So yeah. Yeah. So now with all the data, we can also even plotting a time window. Right? So in this case, I'm going to plot a 2-week window of September. So, oh, sorry, did I say July before? September, sorry. So this, we are going to do pick a 2-week window from September, and then just plot the third column. We're actually now using some package called the ggplot. It's a very popular plotting language. So we're plotting, in this case, what I pick in the TB underscore sub for the subset of the table. And then for now, you can just copy paste this to run this. And what this means aesthetic. We're going to plot from that table. For what we are going to plot, we're going to do using the X, the horizontal one is the dates, and the horizontal one is the dates. The vertical one, what is the vertical one? We use the third column. The third column is what? Alabama. It's probably Barber, Alabama, US. It's probably this. Yeah. So what we are going to do actually, so the ggplot uses something called the additive plotting. So we're going to pick the dates of the horizontal one and the Y or the vertical one. What we are going to plot, we do a point plot, and it's also called a scatter plot. And then what other fancy things we can do is we're also going to add a smoothing line, basically see the trend, what the trend is. So this is basically, we are looking at the changing of the cumulative case of that Barber, Alabama in the last 2 weeks of September. Yeah. So, okay, I think I'm going to stop here. So you can now questions. Yeah, other people. It's 3:30 now, so yeah, feel free to leave. And this is, and tomorrow we'll come back at 1:30 again. Now we can to actually start to pick actually continue to do some interesting analysis.